A very good morning, students. Last videos we have done few chapters and we continue this. Now today we are doing triangulars first part. After that I'll do introduction to trigonometry, application to trigonometry, as well as other chapters to surface area problems, area related circles, and then we continue. Let us start. In triangles, mainly Pythagoras theorem deleted. Pythagoras theorem deleted. Theorem related to areas of similar triangles is deleted. We have only two concepts. One is concepts of related to similar triangles, and as well as Thales theorem. Of course, Thales theorem also one of the theorem defined on similar triangles only. What is meaning of similar figures? First, similar figures means in class 9 you people have learned about congruency concept. Congruency means their shape and size should be same, but in case of similarity only shape will be same, size need not be same. So size if shape and size both are same, then they are called congruent. If any two figures polygons are any two figures are same in shape, they are similar figures. If you observe here, these two circles are similar but they are not congruent. But if their radii are equal, congruent, which you learn in class 9. So if you observe here, these two squares are similar to each other, these two squares are similar, these two circles are similar, these two triangles are similar to each other. As we know, these two triangles are similar to each other. As we know, here if two figures are similar, if they are same in shape. Let us continue with one more concept. So here it is given that similarity of triangles definition. Two triangles are similar if their corresponding angles are equal and their corresponding sides are same in ratio. If you take two triangles, let us take ABC triangle and PQR triangle. So if you take two triangles, they are not congruent because they are not in same size, but they are similar if we when the corresponding angles should be equal. Corresponding means which order you are taking. Here angle A equals to angle P, angle A of angle triangle ABC equals to angle P of triangle PQR, angle B of triangle ABC equal to angle Q of triangle PQR, angle C of angle ABC equals angle C of angle ABC equals to angle QR of angle PQR. Then these two are similar. This is similarity symbol, and we know this is symbol for congruency. It is congruency, it is similarity symbol. So these two triangles are similar when corresponding sides are proportional. Proportional means, for suppose if you take AB2 4 PQ 4, BC 3 I took, QR 6, AC I took 4, here PR I took 8. If you see, the ratio 2 by 4 is 1 by 2, 3 by 6 is 1 by 2, and here 2 by 6 is 3 by 6 is 1 by 2. So 3 by 6 is 1 by 2, 4 by 8 is 1 by 2. So corresponding sides are proportional, nothing but same ratio. Corresponding angles are equal. If it is angle A 50 degrees, angle P should be 50 degrees. Angle B 30 degrees, angle Q should be 30 degrees. Angle C 100 degrees, angle R should be 100 degrees. I mean corresponding angles are equal, corresponding sides are proportional. Those two triangles are similar. And again, two figures having same shape but not necessarily same size called similar figures. If size also same, congruent. All congruent figures are similar but converse is not true. Means congruent figures are, we can say, similar, but similar figures need not be congruent. Two polygons are same number of sides are similar, their corresponding angles equal, corresponding sides are same in ratio. Any two polygons we can say either it is square, triangle, pentagon, hexagon, whatever, but it should follow this one. If a line drawn parallel to one side of triangle and intersect other two sides in distinct point, then other two sides are divided in the same ratio. That is called Thales theorem. If a line divides two sides of triangle same ratio, then the parallel to third side, I mean it is converse of Thales theorem. Based on these two Thales theorem, similarity concept, we will do problems. You have according to CBSE syllabus only these concepts. Let us go with next concept. Here it is given, this is called Thales theorem, students. This is called as Thales theorem, basic proportionality theorem. This is Thales theorem as well as basic proportionality theorem also. Thales theorem is defined on based on similar triangles only. So Thales is a Greek mathematician who work more on similar triangles. This is another name of Thales theorem is BPT, basic proportionality theorem. In exam they might ask state and prove Thales theorem, state and prove basic proportionality theorem. First, whenever it is given state and prove, first we will write statement. After writing statement, we will write given RTP construction if needed, proof. What is statement is given? If a line drawn parallel to one side of triangle intersect other two sides in distinct point, the other two sides are divided in the same ratio. Here ABC is a triangle. If you observe, ABC is a triangle and DE is a line which is drawn. DE is a line segment or line, whatever, line segment or line which is drawn parallel to other side. Then we have to prove that it is dividing same ratio, means AD by DB equals to AD by DB equals to AE by EC. So here we have to prove AD by DB equals to AE by EC. So this is RTP. What is given? It is given the triangle ABC DE parallel to BC. That is given RTP. We have to prove AD by DB equals to AE by EC. This is RTP. Now construction. Construction is to prove this one we need some construction, students. What are the construction we are doing? Here construction is, if you observe, students, we have to draw DM perpendicular to AB. You please take DM is perpendicular to AC. DM is perpendicular to AC. EN is perpendicular to AB. When DM is perpendicular to AC, it is perpendicular to AE as well as EC also. Keep in mind, when DEN is perpendicular to AB, it is perpendicular to AD and DB also. Now, to prove this given theorem, according to Thales theorem, first we will take area of ADE in two ways. Area of triangle ADE we can define if you take AD as base. If you take AD as base, EN is perpendicular this one. Again, if you have a BD, if you take AE as base, DM is perpendicular. So we can use both the ways. Triangle ADE area we can write half into AD into EN. If you take AE as base, half into AE into DM. So both the ways we can define. So to prove this one, next concept, next. So students, these results we can continue in this manner. So if you observe here, according to Thales theorem, we can prove that AD by DB equals to AE by EC. From this again we have few more results, that is AB by DB equals to AB by DB equals to AC by EC. So by using Thales theorem, when the values of AC, AB, DB is given to find EC, not only that case, any one of these three values are given to find a third value, fourth value, we can use this result. So we can conclude from Thales theorem that AB by DB equals to AE by EC. So any three values are given, fourth value we can find by using this results. So it is AC by EC. So we can write it as AC by EC when AB dB, any out of these four values, any three given, fourth value we can find by using this result. Even so, in this way, we can solve the applications of Thales theorem. Let us go with next slide. So, next slide, it is given about converse of Thales theorem. Thales theorem is if a line segment parallel to one side of triangle, it divides the remaining two sides same ratio or proportionally. Its converse is if a line divides any two sides of triangle in the same ratio, then line is parallel to third side. It is Thales theorem. But if a line is parallel to parallel third side, and it divides proportionally, so that also we can parallel is given. If it is parallel given, it divides same ratio. That is Thales theorem. It is converse. Converse means a line divides any two sides in same ratio. I mean it. AD by it means AD by DB equals to AD by DB equals to AE by EC. We can prove that DE is parallel to BC. For that, let us take one construction DE dash parallel to BC. By Thales theorem, according to this, by Thales theorem, AD by DB must be equals to AE by EC as well as AE dash by EC. But here, unless E dash and E coincident, AD by DB never equal to AE dash by E dash C, AE by EC. So, E dash and E are coincide to each other by, so DE is parallel to BC. So, to prove converse of Thales theorem, we'll use Thales theorem also. Next again, the similarity of triangles can be defined based on these properties. Two triangles are similar if their corresponding angles are equal. As we discussed, to show two triangles are similar to each other. Congruency property you people have learned in class 9. Now similarity. Similarity means same ratio but not in same area. They are same in shape only. So if you take triangle XYZ similar to triangle PQR, any triangle we can take, students. So if you consider PQR, then corresponding angles must be equal. Corresponding sides are proportional. Proportional means same ratio. So we will use that correspondence. But in case of congruency, corresponding angles equal, corresponding sides are so equal because they are same in area also. Correspondence means if you take XYZ similar to PQR, X is corresponding to angle X is corresponding to angle P, angle Y is corresponding to angle Q, angle Z is corresponding to angle R. That is called as correspondence. If we change order, the corresponding sides and corresponding angles will be changed. If we take XYZ PQR, angle X is corresponding to angle P, angle Y is corresponding to angle Q, angle Z is corresponding to angle R. In the similar manner, XY is corresponding to PQ, YZ is corresponding to QR, XZ is corresponding to PR. For example, here I took 8, here I took 7, here I took 9. For example, students, if I took XY as 8, here I took 16. Ratio how much? 8 by 16? 2. If YZ by QR also 2, then only they are similar. And third corresponding side also must be same in ratio. 8 by 16, 7 by 14, 9 by 18. They are in same ratio, proportional. So corresponding sides should be proportional, corresponding angle should be same, then only they are similar to each other. To say the similarity of triangles, as how like you will learn about congruency properties or criteria of congruence in 9th class, SSS, triple S, side, SAS, RHS, ASA, AAS, these 5 congruence rules you learn, or criteria of congruence you have learned. But in similarity we have triple A, angle, double A. Actually double A is corollary of triple A. If we prove double A by angle sum property of triangles, triple A is applicable automatically. Triple S, side, 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 SAS, side, angle, side. We have similarity concept, these four only. If any similarity rule is not applicable, they are not similar. Once again, I am saying, children, to prove two triangles are similar, we have criteria AAA, AA, triple S, SAS. By using this, how to solve, let us learn. Here AAA means if two triangles corresponding angles are equal, their corresponding sides are same ratio, hence these two are triangles are similar by AAA similarity. Same way, if in two triangles, two angles of one triangle respectively equal to two angles of other triangle, then two triangles are similar, AA similarity. Triple S means same way, but here they are corresponding angles are equal, but corresponding sides are same ratio. That is the difference, students. Please keep in mind. If three sides of a triangle are are proportional to the three corresponding sides of another triangle, by triple S criteria, they are similar to each other. How like we use the CPST, here we'll use CPC. Sorry, in CPCT, how like we use corresponding sides of congruent triangles, here corresponding sides of similar triangles. Keep in mind, students. Next, SAS, two sides are proportional, included angle is equal. Included of these angles are sides are proportional, included angles are equal, then SAS similarity criteria or similarity rule is applicable. By using these four criteria, similarity criteria, we can prove any two triangles are similar. If not possible, they are not similar. Let us go with next slide. In next slide, it is given same whatever we proved, it is basic proportional theorem just before we discuss, students. So we have to prove AD by DB equals to AE by EC. Statement we know, in a triangle, if DE is parallel to BC, then DE divides the remaining two sides proportionally. That is Thales theorem, basic proportional theorem, or statement also they will give. In a triangle, if a line segment parallel to one side of triangle, it divides remaining two sides same ratio or proportionally. Very, very important theorem. Just before we proved, students. By using this, we can prove, and then by using similarity concept, we can prove the ratio. Again, here triangles, this is proof, nothing but we can prove how they are, and these are the similarity criteria. So now let us solve some problems based on similarity. So please keep concentration, students. Here, keep in mind, if already DE parallel to BC, or else one of the side is parallel to side of one line segment or line is parallel to one of the side of triangle, then we will use Thales theorem. To prove parallel, we will use converse of Thales theorem. Once again, I am repeating, children, students. If to prove ratio, sides are, I mean, already parallel given, to find unknown side. If parallel already given, to find unknown side, we will use Thales theorem or basic proportional theorem. If to prove parallel, we will use converse of Thales theorem or converse of basic proportional theorem. Here it is given in triangle ABC, D and E are the points on AB and AC such that DE parallel to BC. Keep in mind here DE parallel to BC given, already parallel given. So 100% will use basic proportional theorem or Thales theorem. Here it is given in triangle ABC, DE parallel to BC. So which theorem we can apply, students? By, you can write BPT, you can write Thales theorem. So BPT nothing but basic proportionality theorem. Some textbook they might give BPT, some textbook they might give basic proportional, I mean Thales theorem. So both are same only. You can write either BPT or else basic proportionality theorem. What is basic proportional theorem? In basic proportional theorem is defined that if you draw any line segment parallel to one side of triangle, then it divides the remaining two sides proportionally, same ratio. AD by DB equals to AE by EC. Same thing we can prove like this also, students. Don't get any confused. AD by AB equals to AE by AC. See, AD by DB equals to AD by DB equals to AE by EC. This is Thales theorem. Actually, by using this result, we can prove three more corollaries. I mean, three more results you keep in mind. Why getting confused by saying corollary? Two more results we have overall. So that is AD by AB. Sometimes they may give same problem. AB value, AC value they will give. So depends on situation. We can prove AD by AB equals to AE by AC. One more results also we have. One more is these three, any one of these three we will use, depends on situation. But everything basic is basic proportionality theorem. One more result is AB by AE. See, AB by DB. AB by DB, same Thales theorem only or basic proportional theorem only. AB by DB equals to AC by EC, same theorem only, but these are results, other results are corollary. So here what is given? AD value is given, DB value is given, AE value is given. We need to find EC. So we will use first result. So keep in mind students, by BPT, if a line segment parallel to one side of triangle, we can write AD by DB equal to AE by EC. First result. AD by AB equals to AE by AC. Second result. AB by DB equals to AC by EC. Third result. Any one of these three results, depends on situation, we will use up. Now these two results are not needed right now. Depends on situation, as I said. So in this particular problem, AD by DB equals to AE by EC result we will use, because AD is given, DB is given, AE is given, EC we are about to find. So substitute by BPT, DE parallel to BC, by basic proportionality theorem or by Thales theorem. AD by DB equal to AE by EC. Here AD value is given 6, substitute. DB value is given 9, substitute. AE value 8, EC we doesn't know. Do cross multiplication. Then we have 6 into EC equals to 6 into EC equals to 8 into 9. So if you simplify students, transpose another side of equality. Here 6 is in multiplication. If you transpose to another side of equality, it will become division. So once again I am saying students, after doing cross multiplication, we have 6 into EC equals to 6 into EC equals to 8 into 9. We need here EC value. So transpose 6 another side of equality, it will become division. So do cross multiplication, I mean cancellation. 3 2s, 3 3s. Again we have here 2 4s, 2 1s, 2 4s. What is left over in numerator? 3 into 4 is left over. 3 4s, 12. If you want AC, for example, they might ask AC. Here it is given, find AC. So we can use that the result directly, but here AB not given. So, but AC is combination of AE plus EC. In that AE we know, if we find EC, we can find AC. AC equals to AE plus EC. Just now I said depends on situation, we'll use the result. So here we need to find AC. Already AE we know. If we found EC, if we add both 8 plus 12, 20 centimeters. We found AC value as 20 centimeters. By using which theorem? Thales theorem. Again, similarly, second question is given. If AD by DB equal to 3 by 4, AC equals to 15 centimeters, find AE. We need to find AE. Here, AD by DB is given, AC is given. We need to find EC. Simple students, simple way we can do. Just now I said one result. AD by DB is given, AC given means we can write like this. AD by DB equals to AE by EC. What is AE by EC value? 3 by 4. By BPT, we can write that by basic proportionality theorem, AD by DB, AE by EC are equal. Already AD by DB is 3 by 4 is given. Here AC is given. Don't get any confused. First we'll find AC by EC value. But by using which theorem again? Please write here clearly, by Thales theorem or by BPT. So by BPT, we can say that the corresponding sides are proportional are same ratio. So by BPT we proved this theorem. I mean we used this result. We got AE by EC 3 by 4. But we need to find what here? AE by EC. We need to find here AE value. Let us go with next slide how to. So we can now just now we proved students this one how to do AE by using BPT. Same way here also same process we have to do. Here it is given AE is given 4 and DB is x minus 4 as we know, and AD is given 4. Here it is AD students. AD is given 4. AE is given 8. DB is x minus 4 because we took AB as x. So EC is 3x minus 19. If you consider according to that, again basic proportional theorem, substitute, simplify, we get x value as 11. So let us go with next slide. This all we will use. These three problems are similar models to Thales theorem. How to apply we discussed. Now let us go with next slide. So next, according to next slide, AD is given, AB is given, AE is given. We need to find CE or EC. So according to given question, AB length 12, so AD is 4, automatically DB will be, sorry, AD is 8, automatically DB will be 4 because 12 minus 8, 4. Again, AE value is given, EC we are about to find. We need to find EC. So to find EC, again basic proportional theorem according to by BPT or by Thales theorem. Anything you can use, children. So by BPT, same we have done all the models till now. AD by DB is equal to AE by EC. That is AD by DB 8 by 4 and here AE is 12 by EC. Do cross multiplication. We get 8 into EC equal to 12 into 4. 8 into EC equals to 12 into 4. After that, if you transpose another side of equality, it will become denominator. After simplification, we get EC value. Whatever EC and CE both are same. In line segment, both are same, children. CE nothing but EC equals to 4 into 12. So if you transpose another side of equality, it will become division. So do cross multiplication. I mean cancellation. I'm sorry, children. Cancellation. 4 ones are 4 twos are 2 ones are 2 6 are 1 into 6 becomes 6. So finally we got EC value or CE value 6 centimeters. Same way seventh one also. Here it is given AB value, AD value, AC value is given. We need to find AE value. As we know, AD by DB equals to AE by EC. Same basic proportional theorem because already DE parallel to BC is given. When DE parallel to BC given, that is Thales theorem blindly. So here if you take DB value nothing but 6 minus 2 because total length 6, the small length 2, AD value DB is 6 minus 2 4 centimeters, and here AE we don't know. If you take AE value as x, automatically EC value will be as it is given AC 9 centimeters, EC will become 9 minus x. So according to by BPT theorem, basic proportionality theorem, please mention which theorem you are applying, which similarity you are applying clearly. So by basic proportionality theorem, we got AD by DB is equal to AE by EC. 2 by 4 equals to x by 9 minus x. Do cross multiplication, students. Then we have 4 into x, 4x, 2 into 9, 18, plus into minus, minus 18 minus 2x. So 18 minus 2x we got, children. So after using basic proportionality theorem, we got 4x equals to 18 minus 2x. Transpose to find x value, write all x terms one side, variables one side, then constant one side. We got 4x plus 2x equals to 18, 6x equals to 18, x equal to 18 by 6, that is 6 1s, 6 3s, where AE value nothing but x, which is 3 centimeters. Similarly, don't get confused, students. It is parallel to EF. I mean, the parallel to side is changing, but the concept is same. PQ parallel to EF. That is why any theorem learn as concept. Don't buttify only for ABC. They may give XYZ. They may give PQR. They may give DEF. Anything they might give. So be ready to apply accordingly. Basic proportional theorem always start with vertex only. If it is PQ parallel to F, from this vertex will start. If DE parallel to BC, from A it start. I mean, which side it is parallel, the two sides were intersecting, from that vertices will apply basic proportionality theorem. Again, in triangle DEF, so it is given PQ parallel to F, parallel means basic proportional theorem, by BPT. So basic proportional theorem or BPT, I mean Thales theorem. Anything we can write. BPT nothing but basic proportional theorem. Some textbook they'll give by Thales theorem. Both same. dP by PE. Please see students. dP by PE equals to dQ by QF. Here AD by DB equals to AE by EC. But here parallel to PQ parallel to EF. So we should start with D. Keep in mind dP by PE equals to dQ by QF. Here dP given 3.9, PE is given 3, and DQ is given 3.6, QF is given 2.4. But here we are using converse of, I'm sorry children, here we have to prove parallel. So to prove parallel, if these two ratios are equal, parallel. If not, they are not parallel. If we see here it is 30, we can write 39 by 30. So doing cancellation, we got 13 by 3. If you do cancellation here, 3 by 2. These two ratios are not equal. So they are not parallel. By converse of basic proportional theorem, it is converse of BPT. Here we used converse of BPT. So by using if to prove converse to prove parallel, we'll use converse of BPT. Already prove if state we have to prove whether it is parallel or not. That is why we have to use converse of basic proportional theorem. If these two ratios are equal, parallel, by converse of BPT. Converse of BPT, they are parallel. If not, they are not parallel. So here ratios are not equal. So by converse of BPT, they are not parallel. What is converse of BPT? Converse of BPT is defining that if any line segment divides two sides of triangle proportionally, that side is parallel. But here these ratios are not equal, not proportional, so they are not parallel. Let us go with next slide, students. So now it is given M and N are on the sides of PQ of triangle PQR, PQ and PR of triangle PQR. For each of the following, state whether MN parallel to QR. We have to prove parallel to QR. As earlier we discussed, if already parallel given, to find unknown values, we'll use BPT or Thales theorem. But to prove parallel, converse of Thales theorem. Keep in mind, PM is given 4 centimeters in first problem, PM 4, QM 4.5, PN 4, NR 4.5. First find the ratio of these two separately. PM by MQ is 4 by 4.5. Simply we can write 40 after removing decimal point. We can write 40 by 45 by multiplying by 10 numerator and denominator. So we can do 5 8s, 5 9s. So ratio is 8 by 9. Similarly, if you take this one next to PN by NR also 4 by 4.5, same by 8 by 9. I mean it, PM by MQ, PN by NR, both ratios are equal. So by converse, please write children reason, by converse of BPT. Some textbook they'll give by converse of Thales theorem. Both are same. By converse of BPT or Thales theorem, both are parallel. So again I am repeating, to prove parallel, converse of Thales theorem. Already parallel is given, Thales theorem. So by converse of BPT or Thales theorem, they are parallel to each other. They are means if ratio we proved this side, I mean from which vertex we are proving, that side we take. Here PM by MQ equal to PN by NR. So MN is parallel to QR by using converse of BPT or by using converse of Thales theorem. So if ratios are not equal, previous problem, they are not parallel. Here equal by converse of PPT, parallel. Once again repeating, to prove parallel, converse of Thales theorem. To already parallel given, Thales theorem. Let us go with next slide, students. So here also it is given that D and E are the points AB and AC respectively. Triangle ABC such that DE parallel to BC. Already DE parallel to BC given. Thales theorem, no doubt. Or BPT. Basic proportional theorem or Thales theorem. BD equals CE. Prove that AB is an isosceles. To prove AB is an isosceles, it is enough to prove AB equal to AC. So given RTP, please write. Given you can write whatever given, prove that before. This total given, children, very easy to get marks here. It is RTP, isosceles triangle means AB equal to AC. We prove to proof by Thales theorem. If it is given DE parallel to BC, by Thales theorem AD by DB equal to AE by EC. But it is given BD equal to BD and CE are equal. So instead of BD CE equal, so we can cancel directly these two because equal. So what we have, AD equals to AE, EC, AD equal to AE. When these two we added, AD plus DB equals to AE plus CE. Already we know BD CE equal. We proved here AD DBD are equal. From 1 and 2, what can we say? When two, we know Euclid's axioms. From Euclid's axiom, if you add equals to equal, the resultants are equal. So AD by DB equals to AE by CE. Already we know AD equal to AE, BD equal to CE. So 100% AB equal to AC. In a triangle, if two sides equal, it is an isosceles triangle. So hence proved. Don't forget to write hence proved whenever you complete theorem, students. So statement, given, RTP, figure, proof. If construction is there, construction. Here no construction. Some cases not required construction. Let us go with next slide, students. So in the next slide it is given three different problems are given. So first problem in triangle ABC, AD is the bisector of angle A meeting side BC at 10, BC at D. Then first one, BD equals to BD is given 2.5, AD CD AB is given 5 centimeters, AC is given 4.2. We need to find DC. Let us take DC as X or DC also you can take. Let us. So if one theorem is there, if any line segment is bisecting the vertex of one triangle, then it divides the ratio of the two sides. Ratio of two sides equals to ratio of the dividing parts of third side. I mean, if AD is bisector of angle A, according to this figure, AB by AC equals to BD by DC. This is angle bisector theorem also we can say. In a triangle, if one line segment divides the vertex angle, then it divides the remaining two sides in the ratio of the other side, or else other side is divided same ratio as like other two sides of given triangle. Means if AD divides equally or bisecting means equally angle bisector of angle A or vertex angle, then it is dividing AB by AC equals to BD by DC. Very important theorem. So according to the angle bisector theorem of triangle, AB by AC equal to BD by DC. This is very important, students. These applications we are doing. So keep in mind this theorem. So if it is angle bisector, it divides the remaining two sides in the ratio of third side. How it divides that bisector of angle. So AB by AC equal to BD by DC. AB value already given here. AB value is given 5. AC value is given 4.2. And substitute the values we know. BD equal 2.5 and do cross multiplication. We have 5 into BC equals to 2.5 into 4.2. If we transpose on the side, means 5 into DC equals to 5 into DC after doing cross multiplication equals to 4.2 into 2.5. If we transpose another side of equality, what happens? DC, we want DC over here. So DC, make it a subject. DC equal 2.5 into 4.2, 4.2 by 5. And do cross multiplication. We have 5 ones, 5 0.5, because children, decimal point is there. 0.55 the 25, but decimal point is there. So it will become 0.5. Again 0.5 into 4.2, 2.1. So DC is 2.1 centimeters. Once again I'm saying, children, if a line segment divides the vertex angle, it divides that opposite side in the same ratio to remaining two sides. Means AB by AC equal to BD by DC. Same application we have next problem also. These all same models. So by angle bisector theorem of triangle, AD divides the ratio of ABAC equals to at the third side BD by DC. Here second problem is given, BD value given, AB value is given, DC is given, AC we need to find. So AB value substitute, AC we don't know, BD we know, DC we know, known values substitute, three values, do cross multiplication. 5 into 3 equal to AC into 2, transpose another side, 15 by 2, 7.5 centimeters. Similarly, here also third problem also same model, students. AD divides in this triangle, AD divides angle A by angle bisector theorem. It divides remaining two sides AB and AC in the same ratio of third side. AB by AC equal to BD by DC. So substitute the values here. BD we don't know. AB here you see third problem. AB value 3.5, AC value 4.5, BD 6. Uh, to DC is 2.8. Substitute and do cross multiplication. After doing cross multiplication, transpose we get, and again we can do cancellation here. 14 0.2 the 14 0.3 the. So if we simplify, students, we get 35, 3.5 into 2, 35 to the 70 actually. So we get 0.70 by 0.3 means 0.3, 0.7 by. So we can write by multiplying by 10, that is 7 by 3. 3 is a non-terminating repeating. 3 2s are 6. You can do anyway. We get 2.33. Approximately we can take 2.3 centimeters, because 3 after, if it is 5 or more than 5, we take next digit. Less than 5, we take same. So 2.3 centimeters. Next slide, children. Angle bisector theorem only, same concept. If divide same ratio, so BD by DC, AB by AC equal to BD by DC by angle bisector theorem. But here BC given 6. So if you take BD as X, DC will become 6 minus X, assuming. So simplify and do cross multiplication, students, because AB is given 10, AB is given 10, AC is given 14. We assumed BD as X, then DC will become 6 minus X because BC is 6. So after doing cross multiplication, 10 into 6 minus X equal to 14X. Then 10 6 are 60. 14X equal to 60 minus 10X, and write all X terms one side, constant one side. Minus can change into plus. 14X plus 10X equals to 60. 24X. 14 plus X, 14X plus 10X, how much? 24X equal to 60. And X equals to, if we transpose another side of equality, become division. So 4 table we can do, directly we can do 12 table also. 12 5 the 12 2 the possible lowest possible we have to do 5 by 2 we got. If you convert into decimal point, 2.5, but actually we require DC value. So DC is BC minus BD. As we know, BD is 2.5, we got X value. 6 minus 2.5, how much? 3.5. You can do cross cancellation like this. 6.0, 2.5. Do borrow, we get 10 over here. It will become 5. Then after 5, 10 minus 5, 5. 5 minus 2, 3. So we have 3.5. In a similar manner, by using angle bisector theorem, we can solve. And fifth one also same. AC, DC, BC given. We know AD is bisecting angle A equally, so it divides in the ratio AB, remaining two sides AB and AC, the same ratio of third side. AB by AC equal BD by DC. As we know, BC is 10, DC is 6, BD becomes 4. Let us take AC as X. So AB as X, or else AB only you take. AB by 4.2 given equals to 4 by 6, because 6 is given, overall length 10, automatically BD becomes 4. So 4 by 6. After transposing one the side of equality, it will become, and do cross cancellation. 2 2s, 2 3s, and 3 1s, 3 1.4s, because 3 14s are 42, but decimal point is there. So 1.4. and 2 into 1.4, 2.8 centimeter. By using angle bisector theorem, we can solve. Let us go with the next slide, students. So in the next slide also, same way we can solve it. So it is given by angle bisector theorem. It is given, so in the figure, triangle such that, but it is converse to angle bisector theorem. Ratio equal given, we need to find the angle. As we know, angle B is given, angle B 70 degrees, angle C 50 degrees. Automatically angle A will become by angle sum property. So after that, AD by AC given, so we need to find angle BAD. As we know, angle bisector theorem, when a side divides two sides, I mean remaining two sides in the same ratio of third side, AB by AC equal BD by DC, it divides the third side equally. By using angle sum property, we got angle A 60 degrees. So by converse of angle bisector theorem, angle BAD is half of 60, that is 30 degrees. So let us go next slide. Next slide also related to same. So we'll do construction. That construction is produce BA to E such that CE parallel to BA. So again, alternate angles, corresponding angles, because according to construction, alternate angles are equal, corresponding angles are equal. 1 and 3, 2 and 3 are alternate interior angles, 1 and 4 are corresponding angles, they are equal. When from 1 these 2, we can write angle 1 equals to angle 4, because 3 and 4 are so 1 and 2 are equal, because it is bisector is given. When 1 and 2 are equal, 3 and 4 will be equal. When 3 and 4 are equal, AC and AE are equal. We know sides of opposite angles always equal in a triangle. It is given AD is bisector. When 1 and 2 are equal, 1 equals to 4, 2 equal to 3. So 3 and 4 are equal. When 3 and 4 are equal, these two sides will be equal. It will become isosceles. So in triangle BCE, you take BCE triangle, children. BCE, these two sides are equal according to construction. It divides similar ratio. So BD by DC equals to AB by AE. We can write AB by AC, because AC equals to EC, because it is an isosceles triangle. So hence it is proved. Let us go with next slide, students. It is given a trapezium. We know in a trapezium two sides are proportional, I mean parallel. If these two are parallel, we can first we will prove. Already we know these two triangles ACOD and AOB are similar to each other. Triangle in a trapezium, please see, in a trapezium as parallel sides equal, these two are vertical opposite angles. Let me take this is angle 1, this is angle 2, alternate interior angles are equal. By AA similarity rule, we can prove that triangle triangle AOB similar to triangle COD. Triangle AOB by AA similarity rule, triangle AOB similar to triangle COD. So when two triangles are similar to each other by CPST, as like you learn CPCT, corresponding parts of congruent triangles, here also corresponding parts of similar triangles AOC similar to AOB similar to CO. 1 minute. AOB similar to COD by AA similarity rule. So when vertical opposite angles are equal, alternate interior angles equal. So by CPST, AO by order C, children, AO by OC equals to OB by OD by CPST. CPST means corresponding sides of similar triangles. Here we know it is 4 by 4x minus 2 equals to x plus 1 by 2x plus 4. CPST. CPST means corresponding parts of similar triangles. How like we used in class 9, corresponding parts of congruent triangle, here similar triangles. After doing cross multiplication, we have 4 of 2x plus 4 2x into 4x minus 2 into x plus 1 by cross multiplication, 8x plus 16, 4x into x, 4x square plus 4x minus 2x minus 2. After simplification, 8x plus 16 equals to 4x square plus 2x minus 2. After writing all terms one side of equality, we have 4x square plus 2x minus 2 minus 8x minus 16. Like terms we know, difference we can do. 4x square minus 8x plus 2x minus 6x minus 16 minus 2, both are negative, we can add up minus 18 equal to 0. 4 is factorized. To make it simplify, 2 is factorized, we can write 2 of, if you factorize 2 of 2x square minus 3x minus 9 equals to 0. If you transpose another side of equality, it will become division. 0 by 2 become 0. So we have finally equation 2x square minus 3x, 2x square minus 3x minus 9, and then apply split term middle term method. We can apply split term middle term method. Product is minus 18, and we can take minus 6 plus 3, because when product is negative, one should be negative, one factor should be negative, another factor should be positive. Larger number we should take negative, because middle term is negative. After applying split term middle term method, we have 2x of x minus 3. To get x minus 3, factorize 3x, 3 plus 3, both the terms, 3 plus 3 of x minus 3 equal to 0. X minus 3 is common binomial. X minus 3 is factorized. When x minus 3 is factorized, we have x minus 3 of 2x is left over plus 3 equal to 0. If we equate to 0, because product of binomial 0 means either x minus 3 should be 0 or 2x plus 3 0. If we equate x minus 3 0, x is 3. If we equate to x plus 3, plus can change to minus, 2x equal to minus 3, x equal to minus 3 by 2, but length never negative, so that is neglected. X equal to 3 is possible, so it is impossible value or neglected value. We'll do this problem also next slide, same manner. So again I said, both by using BPT, again children, by using BPT, AOC parallel similar to COD, by by CPST, AO by OC equals to OB by OD. It is given AO is given 3x minus 1, OC given 5x minus 3, 2x plus 1 is OB by OD. So after doing again cross multiplication, we have this, simplify, and after that divide by 4, because to simplify very simple manner. So after applying split of middle term method, we have 2x of x minus 2 minus 1 of x minus 2 equal to 0. It is similar model to previous problem. We have x minus 2 of, after factorizing, we have x minus 2 of 2x minus 1 equal to 0. Either x minus 2 equal to 0 or 2x minus 1 equal to 0. Either x is equal to or x is equal to 1 by 2. Because if you take x is equal to 1 by 2, for suppose x is equal to 1 by 2, if you take, this will become negative. OD length never negative. So 1 by 2 is not possible. Length never negative. Depends on condition we take the possible. But some cases both may possible. That time, very rare cases. But in general, one should be true, another should be false. Depends on situation, of course. But x is equal to 1 by 2 not possible, so x is equal to 2. Let us go with next slide, students. So with this triangle part 1 is done, we'll do part 2, some more problems based on similarity concept. Please keep on watching, and for other chapters also, students, if any queries, any doubts you have, don't forget to WhatsApp me. My WhatsApp number is 739 639 4288, and please subscribe, share it, watch it. Very useful information up to final examination. Similar models you get. So once again I'm repeating my contact number, WhatsApp number to clarify your doubts, 739 639 4288, 739 639 4288. Thank you, students. Keep on watching, and please get clarification for your doubts. Now we'll continue part 2, students, with next slide.